Hello, everybody, and welcome to today's live stream hosted by JetBrains. I'm Paul Everett, head of developer advocacy. And I got to tell you, I've done a lot of these live streams. Sometimes you wake up and you're like, eh. Sometimes you're like, yeah. Today is, because I'm joined by my good friend to all of us, teacher of everything for developer productivity, Trisha G, head of developer advocacy from Gradle. Trisha, welcome. Thank you. Give us a quick intro.
Thank you very much. It's kind of cool that you're head of developer advocacy and I'm head of developer advocacy. That's kind of cool.
When I was typing this, I was like, hey, that's kind of cool.
It's cool, right? Yes, so I'm Trisha G, head of developer advocacy at Gradle. Many of you may recognize me from being head of Java advocacy at IntelliJ IDEA up until, I couldn't remember, 3 or 4 years ago, something like that. And now at Gradle, I'm doing some of the similar stuff I was doing at IntelliJ or JetBrains for IntelliJ IDEA in terms of looking at how tooling helps us with developer productivity. And fundamentally, it's all the same stuff I was sort of talking about in terms of tooling can help us. We like to be productive, and the fundamental software engineering principles don't really change, even in the world of AI.
Trisha, you told me backstage the T-shirt you were wearing yesterday.
Yes, so I had a T-shirt which I had made for. I was the MC for developer productivity engineering summit. God, it's the end of the day. I'm very tired. In San Francisco in September, and it says vibe coding is not engineering.
There you go.
I was trying not to be too rude about vibe coding, because vibe coding has a place and it's fine, but it's not engineering.
As it turns out, I have a bullet that is almost exactly that. And if you want to see another cool T-shirt from Trisha's with some naughty words on it, you can go look at some of her videos. Okay, the other reason I'm super excited, I have to apologize in advance. I got a little excited about this topic, and I had like 5 hours of material to slim down. So, Trisha, you will do a good job of keeping me on track, right?
Maybe, or we've got plenty of material that we can ask interesting questions and go deep where it's interesting.
Indeed.
So, yeah.
Indeed.
Either way, everyone wins.
Indeed. So let's go ahead and switch over to the slides. And today's topic is, Trisha, if I say vibe coding, what does that make you think of?
Am I allowed to be rude?
You can be spicy and sassy and saucy.
Okay. So I think vibe coding, when I think vibe coding, I think about getting something out quickly, sort of going with the flow, seeing how things feel, prototyping, initial pass at things. But it also makes me remember that there are various organizations I've worked for where the prototype stays in production for a long time, and it can be difficult to maintain in terms of quality and maintainability.
Not engineering, right?
Right.
And so what we're diving into this today to talk about this thing called misalignment, where it's not doing what you would have done if you would have coded it yourself. How can we solve that with this thing that everyone's talking about these days called spec-driven development for agentic and AI? And Trisha, spec-driven didn't exactly fall from the sky yesterday. This has been a part of engineering, right?
Right. I was listening to a conversation with Martin Fowler, which I think was recorded very recently. And they were talking about spec-driven development. Some people kind of maybe somewhat unfairly compare it with some of the waterfall development, where you come up with the specification in advance. I worked at Ford at the turn of the century, and we had requirements, technical specification, then implementation. But it's not just about, I don't think of spec-driven development as being sort of having requirements in tech spec. I tend to think about it in terms of, I like test-driven development. And with TDD, your automated tests are your specification of your expected behavior. So
Indeed.
For me, I think spec-driven development is an interesting thing.
And just to have a little fun at the start, this was something I saw just yesterday about, great, your agent can crank stuff out, but this is what it winds up being for you as an engineer. You're trying to keep everything on track. So what we want to go through today is we're going to talk about the problem we're trying to solve, how we're going to solve it with spec-driven, and those are the things on the left, and they all have demos. So we're going to be hands-on today. Then we're going to talk about some things on the right, what it means. One of these things has a little bit more hands-on code. But I want to remind all of you, hey, we're here to entertain you. you're here to entertain us as well. This is an interactive thing. Over here in chat, post some things and we'll be surfacing them. And time to time, we'll stop and take questions from the audience and answer them. But please, we are all learning this together. So you have questions, but you might also have great ideas to share with us so that we can learn also. Let's dive into what the problem is that we're talking about for vibe coding. These are those classic one-shot prompts where you just walk up to a text box and say, give me an app and hope for the best. And you wind up so far off track and you spend a lot of money trying to get back on track. And all the things that you've typed where you're saying what you want, the specification is kind of lost in the prompt. I'm going to give a demo of this in a second. But Trisha, if you could kind of get us grounded on why do we write specifications for the lifetime of a project rather than just wake up one day and start bashing some code in?
Well, first, I'd like to say we do write specifications for the lifetime of the project, right? Because I think that it's tempting as a developer to hear like an idea or pick up a Jira ticket or whatever, and then start, even without AI, start banging out code and going, oh, it sort of works, it's kind of fine. But then when we come back to it later on and someone has a problem with it, or there's some sort of like, I don't know, the build fails or whatever, and we look back at this thing going, I don't remember what I did and I don't remember why I did it. And one of the things that I find things like automated tests and specifications and, let's be honest, comments is quite good for are things like, why was I doing this? What was I trying to achieve? And not just lines of code that kind of make it do something. And at the end of the day, I can't remember why it's supposed to do that.
You know, Trisha, you just made a great point. We talk about communicating with other humans. Well, your future self is almost another human, right?
My future self, the reason why I got into developer advocacy, because my future self has no memory whatsoever. And so I started writing blog posts and comments and clean code and all those things, because my future self looks at what I wrote before and went, I don't know what this is.
What was I even thinking? So let me give a demo of one shot, and then I'm going to come back and Trisha and I are going to talk about this a little bit. So, hey, I've got an app. It needs a reload button. Let me really be helpful and just say, go make a reload button. I am in PyCharm, one of the JetBrains IDEs, and I'm in our agent called Junie, which is really tightly integrated. I'll go ahead and let the cat out of the bag a little bit. We also have something called AI chat that has Claude integrated, and soon Junie will appear here as well. But let me go back to Junie. I'm going to fire this thing off, and we got these knobs on here, Brave mode, where you let it take actions on your system. Think more, which is where I want to run my credit card bill up. I'll go ahead and shrink this down just a little bit, and those words will go away. And so I'm going back to, this will take about a minute. And Trisha, you have a line that you say, measure, don't guess. And you talk about it in terms of the life cycle of development, getting to production, continuous integration, all the things. Can you talk a little bit about what you mean when you say measure, don't guess?
Yes. I mean, firstly, I stole this. It's not my line. My old boss, Martin Thompson, used to say it. My friend Holly Cummins says it. Kirk Pepperdine, also a performance tuning expert in the Java world, he says it as well. The whole point is that if you want to get good performance, the first thing you need to do is measure where you are.
Yeah.
And then make changes, and then measure where you end up and go, did I end up where I wanted to be? Have I improved things or not? Especially when this comes from application performance tuning. And we're always tempted to do these sort of micro optimizations. And often what happens is we do them thinking, great, I just made the application faster, but actually you have no idea because you didn't measure it. And more often than not, it's not some, string concatenation thing that's a problem. It's the fact that you go over the network 27 times for one call. That causes performance problems. So it's really important to measure where you are, and then after making some changes, measure where you end up and go, is that what I wanted to do? Now, it applies to application performance. It applies to developer performance. It applies to pretty much anything where you want to make improvements. You have to figure out where you started, look at where you ended, and go, did I do the thing that I wanted to do? And we talk about it at Gradle because Gradle has another product, which isn't the build tool, which is a product called Develocity,
Yes.
which measures, like collects all the information about all your builds, all your build and test times, local machines, CI machines, and it can tell you, hey, did you know that like these people have real problems with their build times and it's an issue, or these folks have the same tests failing over and over again as these folks, and maybe if you address that problem, maybe you could sort of fix the whole team's problems. So you sort of need visibility on what's going on, otherwise you can't fix anything.
I found that talk of yours fascinating that showed velocity on it. And all the things you're talking about, measure, don't guess, for getting to production and build caches and all these other things. A lot of those principles are the same for agentic steering and this misalignment problem that we're talking about. I had an experience a few Saturdays ago where I woke up and like, I'm going to do this awesome Python thing today. And by the end of the day, I just wanted to quit and be a ditch digger because I was so far down rabbit holes of rabbit holes. And I woke up the next day, I slowed down. You know, runners say you have to run slow to run fast. And all the things that Tricia talks about in these talks for software engineering, I think they apply to today's topic. So let's get back to what Junie did. Took about a minute and a half. And Junie tells you its plan. It checks things as it goes along, and it gives you updates on all the things that it's looking at. But I didn't give Junie any real instructions, and this is what I got. And it's just not really like the rest of my application. I looked at it yesterday. It doesn't fit the standards. I could come over to Junie and go to a guidelines file and steer it a little bit, but that's for everything, not just this one feature. And I'm now left in a spot where I go read the code and start steering again. So that's a little bit of the nature of the problem. Tricia, do you want to add any points on this?
I absolutely do. I like the fact that you've picked this example because we didn't think on this beforehand, but like I quite often give the example of, as a developer, the business comes up to us and says, add a big red button that does a thing, right? That's the example I use all the time. And I talk about how software engineering and being a developer is not to go, okay, I'll add a big red button, but to ask, what do you want it to do? Why do you want it to do it? Under which circumstances do you not want it to do certain things? And our job as a developer is to not just implement big red button, but think through the process of what do they want? How am I going to do it? And what are the trade-offs?
Yes, we're going to get back to that later. And we didn't think on it. A lot of these ideas come from a talk from someone from OpenAI that talks about specification. And I want to come back to what Tricia was talking about engineering. Y'all, does this look like engineering? There's no universe in which those 1, 2, 3, 4, 5 words count as engineering.
I think I've worked in teams where this was engineering. Do a thing.
We have some questions coming in. Our colleagues are handling them pretty well, including some requests for new features in our products. Please give us some of that because this spec-driven thing, I want it to be a big deal for us. Okay, the solution, spec-driven. What we want to do is we want to fix misalignment because this is what I've been saying at conferences. I hope that this appears on camera. With AI, you can go really fast in the wrong direction. You want to get back on track. How do you get back on track? Well, you as the human know what your company wants from the big red button, but you also know the last 10 years of policy decisions. How can you express yourself to the agent with specs more than just rules? How can you steer the agent? And this comes from a blog post from my colleague, Anton. Wonderful blog post that he's the one that got me out of the ditch a few Saturdays ago. And with this blog post, it is a summary of what you can do with spec-driven in our IDEs today and starting some ideas that we'll explore later. And so you first start with clear requirements. I'll go through the whole blog post and then we'll do it bit by bit. Write your requirements. Let the agent generate the specification, the plan. And then from the plan, let the agent create the task list, and then you start coding. You don't just jump into the big red button. Tricia, do you have anything you want to comment on this before we get into the requirements?
No, I want to see you do it.
Okay, great. So the requirements, as Anton says in this, when we're doing the requirements, try to avoid jumping right into how to do it. Talk about what should happen, not how to implement it quite so much. Let the agent help you on that process. Stay back at the high level where the humans are and what their business goals are. So what I'll do is I will take the contents of this requirements file that I wrote, and I'll make this, I'll shrink that down a little bit and shrink that a little bit too. And so I wrote about server reloader requirements. And first, I want you to write some tests and then go off and write some code. And this is what the UI layer should look like. This is what the backend should look like. We are all good. So let's take this first step and go starting the process of this spec-driven approach. So in the spec-driven approach, we're going to write a plan. We have the requirements. Now we want the implementation plan. But as Anton says, we're going to let Junie write the plan. We're going to tell Junie to look at that requirements file we just did, and Junie will create the implementation plan. Trust me, this is a good idea because these agents can think of things you wouldn't have thought of. And it's a little bit, I don't want to say humiliating, but it's a reminder that there are a lot of things that you will discover later that it can discover up front. So with this in mind, we're going to go do a demo. And this is what Trisha wanted to see. I'm going to use this prompt from Anton's blog post. I'm going to use this prompt. I'll go ahead and copy it to get Junie to write the plan for me. So I'm going to come down here in Junie. I'm in the same chat where it's got some of its context going. And I type this in and I say, go. And then Trisha and I talk for 1 minute and 34 seconds, just guessing.
Your Slack is scaring me. You've got unread messages. I don't like it.
Sure. So on this planning part, Trisha, you also talk from an observability perspective. We're kind of in the mode where we're saying a little bit up front, what are our expectations? But from an observability perspective, how can you tell whether you succeeded?
Well, that's also why it's important to know where you want to go. So for
Yeah.
performance testing, then you want to pick a number, whether it's, I don't know, like we look at in Gradle, we look at things like total build time. So you look at total build time and it's like 5 minutes, 6 minutes, 10 minutes, 20 minutes. Some people it's much higher. And you might want to, it might be as simple as we just want that to be smaller. Or it might be we want it to be 25% smaller, or it's not doing what we want it to do. But you do have to think about that in advance, really, because otherwise you're just going to game the system with the metrics that you pick.
Yes. Yes. And Trish, I'll get you to talk about path to production in just a second, but I see 2 questions over here that I want to, I wish I could pop them up. But John Cricket was asking about TDD. I'm going to cover this a little bit later in Agent OS. And what it does is really cool from the testing approach. And then Artie asked the question, what is the value of the plan itself? If we just typed it all in prompts, that all goes away later. No human can walk back up and recreate all of the important business points you expressed in those boxes. So write them down in a structured way in the file and then start doing tasks from there. Trisha, you also talk about path to production, which also sounds to me like the life cycle of agentic development. Can you tell people what you mean about path to production?
I'm generally thinking about the fact that, so we've talked a bit about observability and how observability is important. We think about observability in terms of production, like are our applications running? How many errors are there? How long do users wait for certain things to pop up? That kind of thing. And what we often don't talk about in observability is the path to production. So when we write code on our machines in our IDEs, which is the thing I focused on a lot, especially when I worked at JetBrains, it's not done, definition of done. It's not done when I finish writing the code and I commit and I push. It's done when some customer is using that, ideally when some customer is benefiting from it. So there's a whole path from where you commit from your local machine to when it gets into production. And that path, like it varies from place to place, of course, but we're talking about things like pull requests. We're talking about things like
Yeah.
merging. We're talking about CI. Different people do CI in different ways. We're talking about our continuous delivery pipeline, which I hope has gateways which stops code getting through when it doesn't do what it's supposed to do. So you're supposed to pass your unit tests, your integration tests, your performance tests. And at some point, if you don't meet those criteria, it shouldn't go to production. You should stop it on the path. But what we often don't look at on that path is how many times do things fail in integration versus unit test, or how much time does it take on each of those parts of your pipeline? And are we seeing the same kinds of problems again and again and again? Because if we are, we should do something about that. So this
And
path from
in the life cycle, I came back to an earlier point, security.
yes, and that's the other
And
thing.
that's part of the life cycle that has to be defined for acceptance testing, right?
100%. And often security is done right at the end, or it's done, we're trying to think about it in advance when we don't really know what we're doing for security. We look at security in pull requests, but we don't really know what we're looking for. We do dependency scanning and that kind of thing. If you can weave the security story in right from the beginning, like, did the developer build this with a dependency which has got a known issue, for
Yep.
example, right at the beginning, or like, did we rebuild something halfway through our pipeline and now we have different dependencies, or now we've, I don't know, integrated a different tool which is causing different problems? Like, we want to see that all the way through. We don't want to be thinking about it right at the end and having to undo all of that work and start all over again.
And this can be part of the steering that we're talking about so that the agent does that instead of you, right?
You want to shift left. Everything where possible, you want it to be as left as possible. Now, for JetBrains, this is a great story because you don't get much more left than the IDE, right?
Oh, yeah.
You want everything inside the IDE. But yeah, the earlier you can find something, the faster and cheaper it is to fix, which also means that you need it to be fast. Otherwise, you can't shift it left because it takes too long.
Artie Gold had a follow-up saying, so the plan is like the compiled version of the requirements, and that is a great way to think of it. Let's take a look at what the output of this first step from Anton was. And we see a diff. I guess I'll make this a little bit wider. This is what it wrote from my specification. So this is the development plan that it intends to follow. And this is my job now, is to look at this file, read it, make sure I agree, edit it for a place that it's wrong, and then commit it and continue. And so I would, for each one of these things, I'd make a branch. I would do all of these things, commit, and then go on to the next feature for a spec-driven process. When you start reading these things, you're like, oh yeah, I forgot about all that. I forgot about all of this stuff. Wow, I would have never thought of that. And it will start dawning on you that this is going to be a good way of working. Trish, you want
I
to add
love
anything to that?
Yeah, it's like test-driven development for me. So when you start thinking about stuff, so you've asked for a reload button, so you're like, great, I can do reload. But with something like TDD or spec-driven development, you start thinking, okay, but what if the user presses the reload button twice? What do I want to do? Is there some sort of pause I need to add, or like? So writing all that stuff down gets you thinking, what if, what if, what if, and that's where we want to be as developers.
I just had a request to put the blog post link in the chat. When you see me looking over here, I'm not over in company Slack talking about the breakfast or lunch menu. I'm actually reading the chat comments over here. Okay, let's go on to the next point. So, Trisha, we now have written our requirements ourselves, and we pointed Junie at it to create a plan. Now we need to do some work and have some clear, actionable tasks. When I go over to what Anton has written for this, creating a task list, we want to get Junie to make the task list, to read the plan that Junie just wrote as input and make a task list in a style that fits my way of working. And what we'll do is we'll use another prompt, which is saying detailed and enumerated, and group the tasks with checkboxes, etc. And this is going to be a file that's going into version control so that humans can steer it, but humans can, future Trisha can walk up to this and say, oh, yeah, I totally know what was going on there.
And this is useful not
Trisha, do
just
you
for
want to comment
coding.
on this?
Yeah. So like I can imagine me using this for things like, today I need to achieve this, 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 and this. Can you break this down and give me some tasks and things like that? Not
Yeah.
just code, but like don't forget to call to book lunch or whatever, like you were saying.
And Trisha just said something that really is a hidden gem to this. She said today. There's a tendency to walk up to this machine, this godlike machine that can do the universe, and try to do too much at once. Do tiny little steps, review everything as you go, and you'll find that you're staying on track.
This is something else that we've been talking about at Gradle, me and the CEO, Hans. Like we've been talking about how small batch sizes are so important for AI, because with AI,
Well said.
it's so tempting to just kind of, like you said, go down the rabbit hole and create this big thing. And then when you want to back out, you're like, I don't even know where I live now. It's just so huge.
That's what happened to me that Saturday. Like, why I missed my true career. It was not this. And Trisha's right. It's those small units are good for better, faster, and cheaper. Better, as Trisha just described, faster because the context window doesn't get so big and it's always constantly having to clean out the window and stuff like that, which also means cheaper. It's not wandering around going down loose rabbit holes and things. It's focused and it has a better shot at getting it right the first time.
And it's so much better for us as developers because it's less context switching. For like our context window is smaller as well. We
Oh,
know
well
what we were
said.
trying to achieve here. This is the thing we wanted to do. Does it do that thing? Great. Now I can move on.
Well said. My context window is more like a little thing on the side of a ship, one of those portholes or something. Okay, here we are. I'm going to give a demo of this part. We're going to go from plan to tasks. You see in my version control, it wrote the plan. Over here, I've got my agent. It told me what it just did. I can see more detail on it. I can make the window wider so you can see as it goes along. And I'm going to tell it to do the next thing. And I'm using that prompt that Anton had. Read the contents of the plan, write a task list. This is what we just went over. So I'm going to tell it to go off and do its thing. And we'll be back to visit Junie in a second, or more like 117 seconds.
So you called me on this webinar, sorry, live stream, so that you had someone to talk to while I was doing stuff, right?
Well, also you are the wisdom factory.
Oh, that's
So
adorable.
you are the one. This is all about misalignment and keeping us on track. There's a ton of theory behind that with developer productivity engineering, DPE. And Trisha just had a conference a couple of months ago about this, right? DPE Summit?
DPE Summit, it was in San Francisco in September. And we had a whole bunch of talks on developer productivity engineering, which is basically using tooling to help us as developers stay productive, like in a good way, not in a kind of like, let's not use developers anymore. And we heard from a whole bunch of companies like Meta and Airbnb and Netflix, but also a bunch of like the big banks and big enterprises where they're talking about, a lot of them were talking about AI. How do they stay on track? How do they figure out, like we were talking about, how do they measure whether AI is giving them value or not? Are
Hot
they getting
topic.
value from it? Exactly. And it's interesting because, and actually JetBrains was there as well. So the JetBrains research said developers feel more productive with AI, but when you measure their productivity, they're not always more productive with AI. So that's interesting too. Like we feel productive because we're producing stuff, but we might not be producing the right stuff, which is
Haha.
why the spec-driven stuff is more interesting. Is it achieving the thing we wanted it to achieve?
Yeah. And what I've been saying recently related to that research you just said, if this is the next 10 years of that feature, I hope that I'm can't see myself. If this is the next 10 years of that feature, this is the vibe coding part. This is what Trisha's talking about for the full life cycle, get to production and live with it for 10 years. And this is where the engineering happens.
Yeah.
Okay, while it's going, let's talk a little bit about this step. The subject came up in chat about tests and TDD. Do tests make you more productive? As it turns out, getting test first into spec-driven development is a great way to steer the agent to the correct conclusion. Trisha, you want to comment on that? This is your quote.
Is it? Okay, now I have to look at it. I can't see it properly.
Yeah.
Oh yeah, do tests make you more productive? I've been giving a talk at a bunch of conferences over the last 2 years or so about, because I'm talking about developer productivity, and because I feel very strongly about testing. A lot of people were sort of saying, but I don't feel very productive with tests. And so I've been talking a lot about why tests do make you more productive, and the sorts of things that you can do to help you in the bits that you feel slow when it comes to testing. Obviously, the IDE is great at generating tests. You can use the AI tools to maybe generate tests, but maybe we'll see that. But also the thing that slows us down when we're writing tests is thinking. It's thinking about what the code should do. It's
Yeah.
thinking about what it shouldn't do and how to deal with failure. And regardless of whether you write tests or write production code, you still need to do that thinking.
So that leads to the second bullet point here, which matches what Joke2K is saying in chat, that sometimes the agent, just to make you happy, will go mock out your tests and make things pass that are actually failing. And so, Trisha, you pose this question. These agents can write a ton of tests like that. But you pose the question, should you let the AI do it? What do you think?
I mean, I'm a TDD person, so my instinct is to say no. However, I think that getting AI to write, if your code already works, if you've got legacy code, by legacy I mean something that's out there in production, has been there for a few weeks. But if you've got code that's out there and it's working, particularly legacy code that's a few years old, getting AI to write tests that proves the code does what it does is not necessarily a bad thing, because the code already does what it's supposed to do. Otherwise, you would have found that before. I'm not a huge fan of getting AI to write tests for the code that it wrote, because I feel like all you're getting is a whole bunch of nice green checkboxes, which is why I think the spec-driven development is interesting, because you've got this extra layer of why do we want to do this thing and how are we supposed to do it. Whereas if you just kind of say, go and do a big red button and then write a test that there's a big red button, I mean, who's to say what's correct in any of that?
Indeed. And for that, there's another point you made, this third bullet, that reminds me of something I saw on Reddit yesterday, where there was an argument between two people, and one person's like, I'm too busy to do anything, even docs, just agent, write the test, write everything for me. This is a quote from you, Trisha, that we're doing this work. We're slowing down in the beginning to write these specs down, because later it will save 10 times more time than it took to write. Do you believe that?
So one of the things that Develocity does is helps us to troubleshoot problems, specifically around builds and tests, if you've been running them from Gradle or Maven or SPT. And so I've been spending the last couple of years thinking about, okay, how does this observability piece help with the troubleshooting side of stuff, which made me start thinking about, how do I troubleshoot? What do we do when we're troubleshooting? More often than not, when we're troubleshooting test failures or code that doesn't work or whatever it is, we just spend a lot of time poking at the code and putting in log statements and trying to look at the debugger. And we spend a lot of time going in circles trying to figure out what does it do and how did it get here? And troubleshooting is so time consuming, because you all know, you've all done this, where you've spent days, weeks trying to find a problem, and the fix is one line of code or
Oh,
one or
yeah.
two characters,
Oh,
right?
yeah.
Which is why lines of code as a productivity metric are absolutely useless, because it's all the time spent reasoning and thinking and finding and reading.
Yep.
But if when your test fails, let's say a test fails, if your test fails in CI and your test has a good name, it's well structured, it clearly sets out the setup criteria, the testing criteria, and the acceptance criteria, and when that fails, you've got a much better chance of going, okay, oh, did this behavior actually change at some point, like intentionally, or has something broken somewhere else? So you've got a much better chance of
Sure.
figuring out what's the root cause of this and where do I start looking? So if you
Sure.
have those automated tests, and they're well written, then you don't spend as long
And
looking.
that's the key point, because 6 months from now, you'll be looking at them and wondering what you were thinking. We have some
Yeah.
really good comments here. Don's saying part of what you're building is building the product knowledge, and this is like the full lifetime of what you're doing. Chris Brousseau has a comment. Tricia, you make in your talks, measure twice, cut once. And then Artie says tests are like theorems. They're things that you believe to be true, and you need to prove that they're true.
Yeah,
Which
and
I think is
stay
a great
true.
way to put it.
Yeah, and actually one of the points I make in my talk about testing is that your tests have the most value when they start to fail. Right? When they're passing, yeah, it's great, it's
Yes,
brilliant. But
you
when they
do make that
fail,
point.
that's when they give you the most value. So it is
Yeah.
like a theorem. Like if you've disproved something, you're like, oh no, is my hypothesis incorrect, or is what is the world incorrect, which is your production code?
Right. That's a great point, that failure is actually a good thing, not a bad thing. Let's get back to the last step. We want to actually generate some code now. We've got our requirements, our plan, and a task list. Let's go do some work. Here's what Anton's saying about managing the execution. Don't just jump in and say, go do it. Do it in little chunks, work in phases, get the list updated with check boxes. As the human, work in small steps, go over to the Git panel and look at the changes, watch what the agent's doing, etc. So, for example, we'll see the file in a second. This is the prompt that I would use. And when I look at the tasks are like phase A, phase B, and I would review all of this. I would do a commit, and then I would go on to the next step. And the next step will be telling the agent, go look at the implementation plan for phase one and mark things as completed, but only one step at a time. And it's going to go off and do its work. This won't take too long. And you really do want to commit as you go so that we have little pieces as we go.
Small batch sizes.
Sorry, Tricia, can you say that again?
Small batch sizes.
Small batch sizes. Now that we're in the code generation mode, this was Tricia. You used to always talk about this. We spend so much more time reading code than writing code. Do you want to talk about that a little bit?
Yeah, I actually tried to find some statistics for that. I couldn't find any good studies, but like numbers are kicked around, like we read code 10 times more than we write it. Probably these days with AI, I would say we read code significantly more than we write it. But we haven't been taught the skill of reading the code. We've learned the skill of reading code because that's what we do all the time. But no one sits us down and goes, right, this is how you read code. This is the best way to understand things. We learned this the hard way when we're doing like reviewing pull requests and doing code reviews and things like that. But we sort of come to it with our own baggage and our own opinions, which I find really interesting about code review.
Sorry, back to Junie. It needed more information from me and it asked me questions. And so I can very tersely give it a little bit of steering and it will go off and continue doing the work. And it will generate the code and all of the things that go along with these standards, including writing tests up front. So this works out really well in all these agents, but especially Junie, which is really well integrated into our IDEs. Talk to you as it goes along, maybe asks you permission to run commands, things like that. And this is like you're talking to someone who's doing the implementation for you. The agent will ask you questions. You will do some steering saying, no, that wasn't what I wanted. Do it this way.
I love this. I love the questions that come back because sometimes you're like, oh, well, of course, do it this way. And sometimes you're like, oh, I don't know. I didn't think about that. And it's cool.
Yeah, indeed. Indeed. Okay, so as it's going off, we're going to go to the next step where we talk a little bit about what this all means. And these are just ideas. This field is moving so fast that you shouldn't think about that's the way to do it, or that's the IDE to use, or that's the implementation of specification. Instead, look at patterns, look at ideas, and start trying some things. The first is this video from Sean Grove, which is extremely provocative. His point, and it came up in chat earlier, is, if you think about Java or you think about Python, and there's the compiled code, But then there's the source code which generated that. Which one is the valuable thing that you check into version control? It's not the final implementation compiled version. It's the code, which is a specification. Well, if we're talking about a step before that, where a specification generates the code which gets compiled, then spec is the new code. And people who are good at writing specs will be the best developers. Trisha, is this too far for you?
No, because I think it still aligns with the fact that I think if you do TDD, you're a better developer
There
because
you
it
go.
forces you to think about the expected behavior and how do I check, how do I test that the expected behavior is as I expect. And so I think specs are like this as well. I know there are some tools which kind of go full. There's an article on the Martin Fowler website about
We'll
spec-driven
talk about
development.
that.
Okay, and some of the tools go full on in that you can't even touch the code. You can only touch the spec. And I don't think I would go that far
Sure.
because like I'm a developer and I want to touch the code. But yeah, I mean, why not have the specification is in the same way that when we moved to doing continuous delivery and DevOps back in 2010-ish, something like that, we started checking configuration into version control. We started making everything automatable. Everything was checked in so that your environments could be the same wherever you deployed them.
Ah, yes.
It's exactly the same thing. You want to be able to give the machines the same groundwork so that it can follow the same instructions. Obviously, it's non-deterministic, so it's a bit more interesting. But without the specs, it's going to be even more on non-deterministic.
You know, I at booths earlier this year, I really made fun of the non-deterministic part, but I'm seeing the value of that because it asked me questions I would not have asked myself.
Yeah. I see my husband does a bunch of agentic coding, and he does things like here's all the specs and here's all the requirements and everything. He'll send 3 agents off to
Yeah,
do 3 different implementations and just
sure.
pick the one that he prefers. You're like, okay,
All right,
why not?
we see the result from Junie. It asked me permission to run some tests as it went along, and it had to course correct because things got broken, and it finished. And it gave me a little checklist of what it did. It tells me the files it changed over in version control. You see that I've got new tests and I've got a new implementation for reloading. So Junie did its job and I steered it correctly.
I'm so happy you've got tests.
Yes, I got all the way to the end and I've got great tests. We're going to talk about the downside of this with that Martin Fowler one a little bit later. Okay, this is an active field. There are IDEs like Kiro from Amazon. There is a library framework from GitHub called Spec-Kit that implements a methodology. I'll be showing a methodology called Agent OS in a second. And because every day is a new day, there's a new Google tool called Anti-Gravity, which weaves in some of this planning mode. So I want to talk about Agent OS real quick. And this is a spec-driven system, highly opinionated, built around Claude code. So spec-driven development standards. You write down your standards, your workflow. It follows that on a global project and feature perspective. And comes from Brian Castle. It's open source. And it solves 3 things that I think are really interesting. Alignment. There's not a great process for how we can align on these things so you get the thing that you want. And then second, I wanted to write the code I would have written. How do I tell the agent what I would have written in an effective, efficient, and as Trisha said, reproducible way? But third, if Brian's got a bunch of opinions in Agent OS and I've got different opinions, if the tooling gets too rigid, it will recreate some of the failures that we've seen in the past. Trisha, you and I, let's just say it, we've seen some things, right?
A few things.
And we've seen these waves of rapid
Right.
application development and all these things, no code systems and things like this. And they fail when they are not opinionated enough or too opinionated. Do you have an opinion on that?
I do, especially because I work at Gradle and we've got Gradle versus Maven. And, so there's opinions on how opinionated and how custom and how standard you should be. Uh, I mean, obviously the answer is it depends. And sometimes the answer is, if you've got an opinionated framework or tool, if those opinions suit you, then that's good. You can use that without having to contradict it with your own opinions, and you can just get it to go on and do the things the way you want it to.
Sure.
Having opinionated tools and frameworks saves us a lot of energy and a lot of time in reinventing these things. But if you find yourself fighting the framework, so I know a bunch of people who do Android development. There's like multiple different ways and patterns to do Android development. And if your brain works in one way and you're working in an opinionated way in a different way, it's never going to be a good fit.
Sure.
And sometimes you want flexibility. Sometimes, especially if you're starting something new or doing something different, then sometimes you want flexibility. So of course, the answer is it depends. My personal preference is go for something which is pretty opinionated, which more or less matches what you want, and learn how it works so that you're not working against the tool or the framework.
That was the exact balance I had and found with Agent OS this weekend. And Evgeny just asked a question that matches exactly what we're talking about here, the balance, but in a different way. Evgeny asked, what level of programming language knowledge is expected from the person overseeing this? Do you have an opinion on that?
I mean, it depends. So when I was working on Head First Java, the book, Bert Bates, who co-wrote the first two versions of Head First Java, he said that what they always try and do is they try and teach one level down. So when you're learning Java, you don't have to know binary and assembly, but it helps if you're understanding a little bit about that there is a garbage collector, that there is a heap, that there's things that, fundamentally the objects have pointers. You don't need to know all of that stuff, but it
Right.
helps you have sympathy for my old boss, Martin Thompson, used to call it mechanical sympathy. He was talking about the machines. But if you understand what's happening under the covers, you can get more out of the tools you use. So in order to be effective using the AI tools, you don't have to know everything about how AI works or even how the language works, but it does help if you have some understanding of what's going on to the covers so that you can have some opinions on it and figure out, like, okay, does this look sensible? Does this seem sane? I don't think you have to have been able to write all the code yourself, but I think you should be able to look at generated code and go, oh, well, that feels a bit weird, or that looks great.
Yeah, I'm from the world of Python, and we don't spend a lot of time on how things work under the covers. I joke that 101% of Python developers started coding yesterday. Okay, so this is Agent OS. This is its workflow. It's really fascinating. Let's see it in action, and I'll talk a little bit about my experience with it as a much richer, forward-looking vision of spec-driven development. So I'm going to switch over to chat. And hey, y'all, the people that took time out of their day to watch this live stream, you get to see a feature that no one else yet gets to see. They're going to have to wait a little while.
Ooh,
I have
exciting.
Claude Agent as my agent in our AI chat, and we now support slash commands. So I can take the first step of Agent OS. We don't have autocomplete on it, so I've got to cut and paste it. And I can tell our AI chat to go to Claude and run this custom command, which comes from the Agent OS project. And it's going to go off and think a little bit. And it's going to ask me, okay, well, what is it you want in this feature? And I'm going to tell it this. It's going to help me shape a specification. And this all comes from Agent OS custom commands for Claude. So it's all steerable. And I'll let it look around in the project a little bit. And I don't want you to think too much about Agent OS. Like, I'm not getting you to use it. Just look at things like this that have new ideas about how do I say what I want? How do I keep the agent on track for me, for this feature, for this project, for this company? And it's going to go off and do a few more things. I should have warmed it up a little bit.
I like the idea of Agent OS because part of the challenge about some of this is really knowing what, not just like what prompts, obviously, but
Mhm.
even when we're talking about tests, like what's best practice? Like how much
Sure,
setup should I do? And
sure.
how many tests is the right amount of tests? And
Yeah.
having any sort of framework to start thinking about stuff just really helps cut down the noise in our brains.
And you talked about how Isra steers his agents that are highly specialized for certain functions. That really is a big future for all of us because those really small things don't use a lot of context and can run a lot faster, and you can specify them really well with your style.
Yeah.
And so these are some of the things that Agent OS brings in. Um, Claude Code skills, Claude Code sub agents, all kinds of machinery from Claude. And here's the part that I really like. It goes off, looks, and says, I need some help here. Answer these questions. And I find that it just does such a great job on the questions that it asks. And if I don't give a good enough answer, it'll do a follow-up. And what I want to show is how far I've gone with this week, over the past couple of weeks. I've got all of these specifications that I've done, all these features I've added to a fairly substantial project. And sub interpreters, brand new feature in PyCharm, and it's gone off and written this kind of tasks, starting with tests. Write tests first. In the first step of implementation, the agent is going to go to a sub agent for test writing.
Oh,
And
that's
then
great.
it will start implementing my code step by step with acceptance criteria between each step.
I
And I
love
can
that.
edit all of this before telling it to execute these tasks. Then I do it, I commit, I go on to the next task. It generates a bunch of stuff. I come over to PyCharm's Git and I look and see what it did. And if I don't like it, I go and fix it. Trisha, what do you think?
I love it. I feel like, I mean, I want to play with it myself and see how I would use it.
Yeah.
At the moment, like one of the things I'm using AI for, which was not going to resonate so much with our audience, is producing strategy plans for what we're going to do for advocacy and marketing next year.
Yeah.
Like it's not code, but it's a lot of it is still the same kind of thing. Like because especially because I start from a place of not really knowing how to do this, like we often do with code, and I'm like, hey, I need a strategy. And it breaks it down into tasks and deliverables and dates and things like that. So it's really good to work with something where if you're starting with something vague, you can break it down bit by bit into something more achievable, a lot less overwhelming than just, hey, I need to do a thing that I don't know how to do.
Maybe you're going to write Advocacy OS.
I don't know, but I'm actually thinking about using this to finish
Yeah.
writing my strategy
Yeah.
because at the moment it still seems very overwhelming. Like I have a document, I have a bunch of ideas, I dumped a lot of thoughts in, but what I haven't done is write a specification and have
Yeah.
it come up with a bunch of tasks, which I think would
Indeed.
be really helpful.
And so some of the things that I liked and learned as I went along on this was I just love how it did follow-up questions at the very beginning. And it knew what I'd asked it before. It knew what was in my code. It knows the domain and can ask better questions. I mentioned that it's going to do tests first. One of the lessons I learned was, again, run slow to run fast. Every time I spot Agent OS not doing what I want, stop and go to my global rules so that I never have this problem again. There's a temptation to be like, oh, screw it, just fix it. No, slow down, get better at steering. It also is tapping into all this really interesting machinery and Claude Code and then these other systems and stuff like this, where you have more levers that you can have to control the agents. And then finally, I also showed these acceptance checks. Don't finish this task unless this is true, which takes us back to Trisha at the very beginning talking about observability. Okay, concerns. This is something from what Trisha was mentioning, this article on the Martin Fowler site. She wrote a great article, and it started with 3 levels of adoption. Do you want to do a little bit of specification, a little bit more, or do you want to never touch the code? And if you don't like what code was generated, go back and fix the spec. And along the way, several things that she points out in this. Is this bringing back big design up front? Trisha, what do you think?
It's all about balance, isn't it? I have to say, so I really like what you demoed here. I thought it was cool, and I want to play with this a bit more. But at the back of my head, so there's two things. One thing I really like, the idea of, oh, this is a bit like TDD, which I like, but oh, am I going to have to know a lot more upfront and be a bit more big upfront design? So I see the fears of that. I think if you bite off a big thing like create me a Spring Boot application which does, oh, actually, Paul, you worked with us when we were doing the restaurant booking app
Oh, yeah.
years ago, right? So if your initial question is create a restaurant booking Spring Boot app, you're going to have to do some big upfront design for that, because you're going to have to plan the whole freaking application. But you won't be doing that if you're going, okay, let's create a skeleton web app and get that started. Let's create a web page to list restaurants. Let's create a page to add restaurants. Step by step, small batch sizes. So I don't think it's big upfront design if you bite off very small chunks. And I don't know what might be quite interesting is, how do we trigger in ourselves or in the agent to start saying, hey, this looks like quite a lot. Maybe we should break it down into something smaller.
Well said. Well said. I wonder if things like SpecKit or Agent OS can do that. I'll go check and see if anyone has mentioned that in the tickets. We had a comment that I think was a really good one that, let me get back to it. Do any of these tools give you a bird's eye view of all of the features, all the specs, all the decisions, stuff like that? And we're so new in this. We're just beginning to see experiments with UIs. Like, how can the IDE or some future concept of the IDE organize this process and steer you as you're steering it?
It does sound a little bit like, how do you get U-Track embedded in the IDE? Because you talk about issue tracking and task management.
Yeah.
So
a
how do
lot
you
of
tie
these
those
tools
things?
are CLI tools right now, but we've got a future of kind of surfacing this, right?
Yeah.
Another one that she mentioned I'm really interested, Trisha, in your opinion on this, because you've got that kind of infinity symbol of CI/CD pipeline lifecycle. Her point is, okay, this isn't great for every kind of change you want to make.
Mm-hmm. Yeah.
Or what happens after the change lands.
Yeah. My instinct is that it's fine for new features. In fact, you've got it here, better on greenfield. I can see it working well for new features. Not sure how you would apply it to bug fixes or improvements. I can sort of see, but bug fixes, not sure how you can have a spec that says, hunt down this weird ass bug that I don't know what it is or where it is. Can you write me a test to find it and fix it? That still needs a lot of us. I like the fact that in your spec-driven stuff, you're creating tests, because that's where I think tests can help us. Okay,
Sure.
let's create a test which will find and fix this problem. But yeah, so I can see it being great for demos. I could see it being great for greenfield projects, new features. It's also, well, actually, I would have a question around how it fits in with existing architecture. Can you like retroactively add it to a legacy system? Probably, again, it depends. Like, how big is the system? How complicated is it?
Yeah, you make a great point. Agent OS does start with you writing down at a very high level your mission, and then at a very high level the roadmap. You can see how poorly I did at guessing where I wanted to go. But I admit I am surprised at how good this was for a not greenfield project. I brought this into something that I was already well underway on. And as long as I kind of really rethink how I do things and fit into some of the things that you've discussed today, it is working beyond greenfield.
Yeah.
So I'm a little optimistic. You also talked about tests. This article says, you know what these things can crank out? A lot. They can crank out a lot of markdown specifications to be read and a lot of tests to be read.
Yeah.
And so there's some balance, right?
And this is something we talk about again at Gradle, because we talk a lot about how using AI more creates more code, should create more tests. It should potentially create longer build and test cycles because you've got more code, more tests, more, you're just running them a lot more, and perhaps bigger batch sizes as well, which is why I mentioned batch sizes. So if you are cranking out a lot of tests, then you should give the sales folks at Develocity a call, because like we can speed up your build and test cycles.
I had a bunch of notes about that. It was fascinating.
But one of the reasons why I quite like Develocity, like I work for Gradle, so I don't, in theory, I should say nice things about it anyway. But I think Develocity is cool because if you have a lot of automated tests, which I think is a good problem to have, it'll do cool stuff around how you parallelize running those tests. It uses machine learning to figure out which tests to run, and also we have AI powered failure troubleshooting. So if you've got 400 test failures, it can go, hey, you know what? This is actually only 6 root causes. So these are the places to look. So yes, tools like this can be noisy. AI generally is going to create more code and more tests anyway. It's going to put pressure on your CI builds and your CD pipelines. Other tools can help you. But I think one of the concerns here is when you have pull request and code review processes and you have to read all that stuff and figure out if it's doing the right thing. But this is where I think we really need to be investing in our CD pipelines. We need to make sure the tests are doing the right things. But if we think the tests are doing the right things, we're running them automatically and we fix them when they break, then that's good. That's where we want to be. We want these automatic checks to make sure we delivered what we said we were going to deliver and that we fix it when we break something.
I think that you just said a number of things, like 5, 6, 7 things that seem to be directly traceable to, I need a sub agent to do that, and I need a sub agent to do that and stuff. So there's so much opportunity for tooling. There's opportunity for everything Gradle is doing, because there's going to be this deluge of code. There's going to be this opportunity for what you always talk about. We do more reading than writing. So learn to be good reviewers of code and have tools that help on that, like IDEs, right?
Right. So actually, another webinar I did this time last week for Gradle was around how you can integrate Develocity with IntelliJ IDEA and use the IntelliJ IDEA Develocity plugin along with MCP Server and the AI tooling inside IntelliJ to troubleshoot your problems and start saying, hey, my build failed. What do I do about this? What's the problem? And so this is where our tools, including the IDEs, can really help us with a lot of the problems, which if AI is generating a whole bunch of code, we're going to potentially have a whole bunch of issues that we don't know where they came from or how to fix them. And we can actually use AI and tooling to kind of point us in the right direction there.
Well said. Exciting times at JetBrains. In the next couple of months, you're going to see some really cool stuff from us. Let's start the process of wrapping this up. I've got a quote from Trisha that you got from a poet. I thought it was fantastic for this topic of steering an agent. The agent is this wild animal, and you have to bring discipline to it.
I love this quote because I think when we think about creativity, we tend to think about the wild mind bit of creativity, but you need the discipline or you are not going to deliver what you want to deliver.
I'll answer a question real quick. Will this be supported natively? There's a ticket, and I won't be able to get it to you in time, but it's easy to find me, and I'll beg all of you, if we suddenly have 400 votes for this ticket, then I will have done my job in this webinar. As well as, if you want to try all this, we've got a link in the video description. If you think I've done this a few times, click and subscribe, click and subscribe. You can get more information on this. If we could come back on screen. Trisha, old friend, thank you on guiding us through this trip of agentic development and how to steer things.
Thank you for having me, and thank you for doing the demo so that I didn't have to do it.
Hey, you bring the brain. That's what we need here. And I don't know if you had a chance to see, this was one of the best video chats that I've had in any live stream. There are so many good ideas and conversations out there. I think people are really, really interested in figuring out the solution to this problem that 95% of the people say AI is not leading to productivity.
Yeah, I think there was loads of great comments in there. I was having a look, and lots of people
Yeah.
very, very interested in this. I thought it was cool.
So, best two words in any presentation. In conclusion, thank you all for joining us today. Thank you, Tricia, for joining us. Let's all go on this journey together. If you have anything you want to say about JetBrains and AI, come and find me. I'm fun to talk to, and I'm interested in what you have to say. Thank you for joining us today. Have a good rest of the day.